Alright. 6B lesson 1 notes. So this is called quadratic equations in vertex form. Today's learning target, I can write an equation for a quadratic function in vertex form. Okay, so the main one we're interested in today is right here, vertex form. All right. So we have our x, we have our f of x, which is your y. You have your a, which you know from before, which tells you whether it is steep or less steep. And then you have your h and your k, which are new to you, but that's just the way that they define x and y within the vertex. Alright, first things first, if we look at this graph, where do we find the vertex? We know the vertex is either the highest or lowest point, so that is going to be our vertex. We're going to count over, and that gives us 3. We're going to count up, which gives us 2. So our vertex is at the point 3, 2. They want us to write the vertex as h and k, is what they define it as this time. So h would be 3, k would be 2. The second part to vertex form is you can pick any point you want. Typically, you pick one of the zeros, but if there was another perfect point on this graph, you could choose that as well. For me, I'm going to choose this point right there. That point is going to be 2, 0, where the 2 represents my x and the 0 represents my y. Before I go too much further, this f of x can be switched out for y. So when we start plugging things in, this 0 will go in for that y on the left by itself. So right next it says plug x, y, h, and k values into the vertex formula. So let's see here. The first thing I'm going to have you do is just rewrite the formula to get used to it. So y equals a parentheses x minus h close parentheses squared plus k. Okay. My y value in this case is 0, so 0 equals. My a value we don't know yet, so I'm just going to rewrite a. My x value is 2. My h value is 3. Notice that this negative or minus is a part of the equation. So 2 minus 3 squared plus k, and this time k is 2. Alright, so the first time I go through it, I'm going to go ahead and solve it by hand. So 0 equals a. 2 minus 3 gives us negative 1. Squared plus 2. Right. Next, I'm going to go ahead and subtract over the 2. Subtract over the 2, which is going to leave me with negative 2 equals a. And then we know that negative 1 squared, negative 1 times negative 1 is, of course, positive 1. Now, a and 1 are multiplying by each other, so the way you get rid of it is to technically divide by 1. If I divide one side by 1, I have to divide the other side by 1. But we know that when we divide by 1, that it doesn't affect anything. So it comes out that negative 2 equals our a value. Okay? And from before, our a value is the number that's in front of x squared. So, since this is a negative x squared, that is why our graph faces down. Since this is a 2, that number is larger than 1, so that should make it go inside of the points 0, 0, 1, 1, 2, 4, and we can clearly see that it did. It is inside of that, so it's going to get steeper. Okay. So rewrite the equation using a, h, and k. So we're going to say y equals an a value of -2. X is still x. Our h value from before was 3, so -3 squared plus 2. Okay. So if I was to look at that, y equals -2, parentheses, x minus 3 squared plus 2. Before I start graphing it or anything like that, there's a few things that I can recognize. This is my a value. My a value tells me a lot. It tells me my steepness and it tells me what direction I go. So since this is negative, it should be facing down. Next, since this is vertex form, the reason they call it vertex form is because it tells you your vertex. So inside of parentheses means opposite, so that would be a +3, and this is outside, so it stays the same. So 3, 2 should be our vertex, and we know from what we wrote before that that is in fact true. Last step, we can go ahead and check ourselves to see if we did it correctly. So we turn on our calculator, it says it's in press to test mode, which is perfectly fine. We're going to hit OK. I'm going to go over and hit New Document. No, I don't want to save, and add a graph. Okay. Now I just type in what's on the right side this time. So -2, parentheses, x minus 3, close parentheses, squared, plus 2. Type it in exactly as I see it. Once it's in, I hit enter. Okay. And I can see that it crosses through the 2 that I had before and the 4 that is also there. It's kind of hard to see if it crosses at the exact vertex. If it's hard for you to see, you can always go to Menu, View, and add a grid line. We're going to add a lined grid. So now it gives you those grid lines where it's easier to count. Over 3, up 2. Yes, that is in fact our vertex in our original graph, and then it has the same zeros. Next. Okay, page 2. Now in class, you'll typically try this one by yourself. See if you have a good understanding of what I showed you on the original. But same steps. This time it's facing up, but it's still the same steps. First thing to know is our vertex. This time our vertex is on the bottom, so it's our lowest point this time. That point is going to be over 3, so -3, down 2, so -3, -2, where the -3 is my h, and the -2 is my k. Next, I need to find another perfect point. The only perfect points we have on here are going to be our zeros. So I'm going to choose the one that's -1, simply because a 1 is easier to work with than a -5. So it's -1, comma 0. Alright, so we need to plug them into that equation. That equation was on the previous page, so we're just going to write that equation once more. So y equals a parentheses x minus h close parentheses squared plus k. So let's plug everything in, and then we have to figure out what our a is. So here we go. Our y is 0 equals an a that we do not know. X equals -1 minus h, which is -3. So minus a -3 gives us 2 minuses, give us a plus. So it's going to be +3 squared, and then -2. Because it's plus a -2, so it's really just going to be a -2 there. Right. Before we get to start solving here, I want you to recognize if something's reasonable. So remember the points we learned before. 0, 0, over 1, up 1, so 0, 0, 1, 1, 2, 4. This is our parent function steepness, 0, 0, 1, 1, 2, 4. We can clearly see that our new line is outside of that, which means it should be less steep. And if we're going to have less steep, that's obviously going to tell us that our a value should be less than 1. A value needs to be less than 1. Alright, so here's the math. 0 equals, leave the a there. negative 1 plus 3, or you can look at it 3 minus 1, gives us 2 squared minus 2. Next, add over the 2. Add over the 2, which gives us 2 equals a, and then let's go ahead and square the 2 before we rewrite this. So 2 squared gives us 4. Right? Since a and 4 are multiplied by each other, the opposite of multiplying by 4 will be to divide by 4. And then 2 divided by 4 gives us an a value of 2 divided by 4. If you're not sure about your reducing, or you just want to have a little extra confidence as far as reducing when the numbers start getting a little bit harder, you're going to add a calculator. And if you just type in 2 divided by 4 and hit enter, the calculator is going to reduce it to the best fraction, or the smallest fraction it can. So a equals 1/2. So it's opening up, so it should be positive, which our a value is positive. It is less steep than our parent function, so it should be less than 1, which clearly 1/2 is less than 1. And then lastly, we have to plug it all in and set it up so we can see that in vertex form. So y equals, our a value is 1/2. Our h value, what we plugged in before, was plus 3 squared. And then we put in minus 2 before. Right? That's our equation. So let's go ahead and graph it and see if it matches. I know sometimes it feels like that's a lot of extra work. However, it is a benefit to be able to check your answer without having to have your teacher check your answer for you. So I'm going to type in the equation, 1 divided by 2, parentheses, x plus 3, close parentheses, squared, minus 2, enter. Again, it looks pretty close. For those who want to look a little bit closer, you can always add your grid lines. Okay. I can see that it goes through -1, which is true. I can see it goes through -5, which is our original equation. And I can see that my vertex is to the left 3 and down 2. So that new equation that we wrote is perfect. A value does a lot for our equations. Example number 3. This time they're giving us a table. So the first step for us is to identify where our vertex is. So remember, your vertex is always in the middle of your quadratic, and it also has the axis of symmetry that goes right through the middle of it. So notice how between your 2 repeating zeros there's a -2. In the middle of your 2 6s there's a -2. If the -2 represented a mirror, if a 0 stood on one side of the mirror, it would look like a 0 on the other side of the mirror. If a 6 stood on one side of the mirror, it would look like a 6 at the same distance from that middle. So our vertex here is 2, -2, which means our h is 2, our k is -2. I can pick any of those points. And I don't know about you, but I find 1 and 0 to be nice and easy points. So 1, 0. X is 1, y is 0. Now we've already written the equation up top, so we should have a pretty good idea what it looks like. I'm going to do it one last time for you. Y equals a, parentheses, x minus h, close parentheses, squared, plus k. You don't necessarily have to memorize that equation, but you should have a pretty good working understanding of it. Okay, so our y value in this case is 0 again. Our a value is what we're looking for. Our x value is 1. Our h value is 2, so minus 2 squared. And our k value is minus 2. All right. Now, we can graph these points if we're really curious to see how reasonable our answer is. So let's see what we have here. 0, 6, 1, 0, 2, -2, 3, 0, and 4, 6. If this looks familiar, it's because it is. It was on last unit's notes. Remember, you knew your axis of symmetry. You had to find the missing one, which was the 1, 0 before. All right, so looking at our graph that we just drew, we can clearly see that it opens upward, which means we should have a positive A value when it's all said and done. And then if we look at our numbers, 0, 0, let me switch pens for you, 0, 0, 1, 1, 2, 4, we can clearly see that our new graph is inside of that, which means it should be steeper, which means our A value should be greater than 1. All right, let's see if the math agrees with us here. So 0 equals, add over the 2. Add over the 2. That's going to give us 2 equals A. 1 minus 2 is negative 1 squared. What's negative 1 squared? Positive 1. And then obviously these two are multiplying together. 1 times A, the opposite of 1 times A is divided by 1. What I do on one side, I do the other side. When I divide any number by 1, it doesn't affect it, so A ends up being a positive 2. So once I go to rewrite that, that's going to give me y equals an A value of 2, parentheses, x minus 2 squared, plus 2. Sorry, minus 2. So let's see if our graph matches that. Two parentheses, x minus 2, close parentheses, squared, minus 2, enter. Okay, that looks like the graph that I drew. However, we all know that we make mistakes, and sometimes we don't plot the points accurately. So if you hit Control T, you can recognize that 0 is 6, 1 is 0, 2, negative 2, 3, 0, 4, 6. They all match. So that is also a good sign because these numbers were given to us, so there's no discrepancy. They should match. So really all we're doing here in this lesson is manipulating what you learned in the last unit and displaying it a different way. So good luck on the practice.